আমার ওই যে গুগল ক্লাসরুমটা তো বোধহয় অ্যাক্সেস করতে পেরেছিলে, তাই না? তোমাদের গুগল ক্লাসরুম অ্যাক্সেস করতে প্রবলেম হয়েছিল কারো, না সবাই অ্যাক্সেস করতে পেরেছো? হ্যালো
স্যার, আপনার মেলটা আপনি কি আমাকে মেল করেছিলেন স্যার? টেকনিক্যাল ফল্টের কারণে মনে হয় আমার কাছে আসেনি স্যার।
আই ডোন্ট নো ওয়াই, আমি তো মেইল করেছিলাম সাথে সাথেই, আমি তোমাকে সাথে সাথে মেইল করেছিলাম গত
স্যার তাহলে
ক্লাসে।
এখানে একটু মানে চ্যাট বক্সে যদি কোডটা লিখে দেন তাহলে ভালো হয় স্যার।
আচ্ছা, সেটা আমি দিয়ে দিতে পারি, কারণ আমি গত ক্লাসে দিয়েছিলাম এবং আমার, ওকে তাহলে আমি দিয়ে দিচ্ছি। জাস্ট আ সেকেন্ড। That's ODIN7BQ, ODI7BQ। তো এখন আমি জাস্ট তো তোমরা সবাই একটু দেখো, চ্যাট বক্সে আমি দিয়েছি গুগল ক্লাসরুমের কোড নাম্বারটা ODIN7BQ। দেখতে পাচ্ছ সবাই?
ইয়েস স্যার।
Yes, sir.
ওকে, অলরাইট, ওকে। আমি এটা গত ক্লাসেই ইমেইলে পাঠিয়েছিলাম, কিন্তু সামহাউ প্রবাবলি যায়নি, আই ডোন্ট নো ওয়াই, বাট এখন ডেফিনেটলি তোমরা এটা দেখতে পারবে, কারণ আমি গত ক্লাসেও তোমাদেরকে কতগুলো কনভেকশন প্রবলেম I was expecting that you probably will go through it. You know, they're not really not new as such, কিন্তু প্র্যাকটিসের জন্য দরকার আছে। সো তোমরা যদি এখন যাও গুগল ক্লাসরুমে, you will obviously see the lecture. আমি আমার রেকর্ডিংটা এখনো দেইনি, বিকজ আমার কিছু ডেটা নিয়ে প্রবলেম আছে, যেহেতু আমি 3টা কোর্স পড়াচ্ছি and I only have a certain amount of data, so I don't want to use that straight away. কিন্তু এগুলো fairly well defined lecture notes, so you should be able to follow it. তবে যদি পারি পরে, তাহলে আমার রেকর্ডিং গুলো আছে, I will update it. তো আমার মনে হয় it is the time for us to take a attendance and then go into our teaching. কারণ আজকে আমাদের বেশ কিছু টিচিং আছে, so I want to make sure that I can do as much as I wanted for today. আমি রোল কল শুরু এ দিয়ে, রোল নাম্বার রোল 101 ফাহাদ এনায়েত।
Present, sir.
Thank you. Roll number 102 Faisal Sohag.
Present, sir.
Okay. Roll 103 Selim Al Razi.
Present, sir.
104
Present, sir.
104 Sheikh Al Kamal.
Present, sir.
Okay. Roll number 105.
Present, sir.
106
Present, sir.
Abdullah Zubair. Abdullah Zubair.
Admit, sir.
Okay. All right. So it's in roll 5, Alamgir Hussain Shoykot. Roll number 6, Shishir Khan.
Present, sir.
Roll number
Present,
8,
sir.
Yes, sir.
roll 41, Nuzhat Akila Tushi.
Present, sir.
Roll 42, Fahim Faisal.
Yes, sir.
Roll 43, Qazi Rubayat Hussain.
Yes, sir.
Roll 47, Abdullah Al Adib.
Yes, sir.
49, Nahin Ibn Akbar.
Yes, sir.
Roll 50, Zahid Hasan Shubho.
Yes, sir.
Roll 53, Nafiul Islam.
Yes, sir.
Roll 54, Syed Tanzib Mahmood.
Yes, sir.
Roll 58, Takvir Rahman.
Present, sir.
Roll 59, Mustafizur Rahman Joy.
Yes, sir.
Roll 60, Naimul Siddi. Okay, thank you very much. যদি কেউ পরে এসে থাকো আমাকে just email করবে kindly, then I will update it after the lecture. তো আমি এখন শুরু করতে যাচ্ছি. I better stop the video. তাহলে বোধহয় অনেক সময় ডেটা ট্রান্সফারটা বেটার হয়, কিন্তু I'm really sorry, আমাদের এখানকার ইন্টারনেটটা কেন জানি মাঝে মাঝে একটু ঝামেলা করে, so you have to bear with it. Hopefully very soon we can meet face to face and start the classes properly. দেখা যাক। আর আজকে যে টপিকগুলো করব, which is a continuation from kind of next week's discussion that we were having. তো আমি আমার স্লাইড তো বোধহয় তোমরা দেখতে পাচ্ছ, তাই না? Can somebody confirm?
Yes, sir.
Okay. All right. আমি যখন প্রশ্ন করি তোমাদের মধ্যে যে কোনো একজন পারহ্যাপস ক্লাস রিপ্রেজেন্টেটিভ জাস্ট একটা কুইক অ্যান্সার করলে আমার জন্য একটু সুবিধা হয়। ওকে, সো আমি গত ক্লাসে আমরা এই ডিসকাশন শুরু করেছি এবং ডিসকাশনের মেইন যে জিনিসগুলো ছিল যে আমরা বলেছি যে we will probably our most of the time we shall spend about heat transfer from extended surfaces, which means the fins. আমি মোস্টলি হলম্যানের বইটাই ফলো করেছি, বাট ইউ ক্যান ফাইন্ড দিস থিংস ইন এনি টেক্সট বুকস। অ্যাপ্লিকেশনস আর মেনি এবং দিস আর পসিবলি দি নাইসেস্ট এক্সাম্পলস। এবং আজকে আমরা সত্যি সত্যি কিছুটা ক্যালকুলেশন করব ইনভলভিং দিস কাইন্ড অফ প্রবলেম। তো fins are everywhere. Any heat transfer device will possibly have some sort of fins attached to it. আমি রেকর্ডিংটা শুরু করে দিই, তাহলে পরে যদি সময় হয় আমি আপলোড করব, but it all depends on the situation.
Recording in progress.
So fin tube heat exchangers are very common. When you go to the laboratory, I would ask you to take a closer look at the things and see whether the fins exist or not. But they are really a common kind of attachment or extension to the design of heat transfer systems. So these are other examples of heat sinks. Heat sinks basically means it's a method by which you can lose the heat very quickly, and obviously that is done through using a number of fins. These are other examples. Perhaps you are all familiar with this kind of picture. কার রেডিয়েটরের সামনে গাড়ির সামনে এরকম একটা থাকে যে সবসময় হিট লুজ করতে হয়, and as soon as the engine starts, heat transfer starts immediately, because unless we lose sufficient amount of heat, the engine is going to heat up beyond the acceptable limit, and which is extremely dangerous for the vehicle. এছাড়া আমরা সবাই জানি যে এই ধরনের all other the various kinds of devices will have fins. So আমাদের এগুলো হচ্ছে these are the common kind of fins. Some of them can be radial, and you can see they can be rectangular in cross section, they can be triangular, they can be hyperbolic and whatnot. The designs are really up to the designer. On the other hand, the pin fins are like that. It's a protruding pin that can be a uniform cross section, that can be conical, that can be other different shapes. This is again an interesting thing. আমরা সবাই এখন one time single use cups and mugs use করি, বিশেষ করে যখন আমরা গরম কিছু খেতে যাই, এবং তখন দেখো যে এই জায়গাটাতে কিছু রিজড একদম স্মুথ করেনি। সো ইনফ্যাক্ট এটার দুটো রিজন, একটা হচ্ছে to hold it appropriately and at the same time it allows the heat to be lost. তোমরা সবাই যারা এসব ব্যবহার করেছো, so take a hot tea or hot coffee, you will বলো আচ্ছা আর একটু বড় করে দেখতে পারতে? ওকে ঠিক আছে, ওকে ইজ ইট বেটার? অলরাইট, থ্যাংক ইউ। সো হ্যাঁ, আমি এটা অ্যাভয়েড করেছি বিকজ লাস্ট ক্লাসে আমি এটা কভার করেছি, সো দ্যাটস আই ওয়াজ ডুইং দ্যাট, দ্যাটস ফাইন, থ্যাংক ইউ। সো আমি যেটা বলতে চাচ্ছিলাম যে যখন তুমি এই ধরনের একটা হিটেড কাপ অফ কফি অর টি নাও, তুমি যদি এই জায়গাটাতে ধরো তাহলে দেখবে যে ইট ফিলস ভেরি হট। On the other hand, if you feel here, it is much more easier to hold, and at the same time, since it is losing heat, obviously you will feel a less hot. Plus, arekta jinish obosho, just the very design, it allows you some space in between the two solid surfaces. So these are again the designer aspects. So আমরা দেখেছিলাম যে fins actually it's a combined mode of heat transfer. এখানে conduction আছে, convection আছে. Obviously, first bit will be conduction, and all convection actually starts from conduction, which I think you are familiar with your previous heat transfer course. So it is much more obvious that the majority of the heat that will flow from the solid material is via conduction, and then due to the fact that the surface is exposed to the environment, it will start losing heat by convection. So it's a combined mode of heat transfer. এবং এই আলোচনা করতে যে I just took you through all these basic stuff, so there is really no need for if you are more comfortable, but again I gave all these things as a matter of completeness. So আমরা quickly এই জিনিসগুলো চলে যেতে পারি. There is no need to spend too much time on it. And for convection, we discussed that this is basically the equation Q equals to HA delta T. And H is the tricky quantity because it is the heat transfer coefficient. And I already mentioned to you last week, and I will possibly reiterate a few times in my next classes, that the value of the H is very tricky because it depends on so many factors. I showed you a little video last week, and there are plenty available in YouTube and various other places. So H is a tricky quantity, but let's say for the sake of our calculations or all the problems that we'll be following, we'll take given a value of the H. And the reason the value of the H is, H is a little bit uncertain or tricky to find out is because of the boundary layer which exists very close to the solid surface, and lots of things that happen, and obviously H suffers from a big range of uncertainty. And then we talked about these things, that these are the numbers you are all familiar. Nusselt number is related to the H value, which is the heat transfer coefficient, and Prandtl number is a ratio of the three properties of the fluid in question. And Reynolds number, on the other hand, it tells us the ratio between the inertia force over viscous force. So I think you are all familiar with such things. And then I gave you one or two examples to try, which I'm sure you should do before next week. Because I don't know, some or other Google Classroom information was not, was not available to you, although I sent the email. But again, this can also happen to natural convection scenario. And for the case of fins, perhaps natural convection and forced convection both are equally common. If I'm correct, it is probably natural convection is more common. But again, the other one is also there. If it is a natural convection, basically what happens, you've got a heated object and then the fluid around which will be heated, and then it will flow naturally up and it will set up a flow regime which will take the heat away from the heated surfaces. And the analysis is very similar, that we can think about a boundary condition along a vertical wall, and then again you come up with Nusselt number relation. So again, Nusselt number and Prandtl number are the same. The only thing different is the Grashof number. And the Grashof number is a little bit messy kind of expression, but this is how it is defined. So after we have known the Nusselt number, obviously we know the value of the H. And then we can solve the conduction convection problem. And one of the best examples is perhaps fins. আমি কয়েকটা problem দিয়েছিলাম তোমাদের. And this is what I suggest to everybody, that when you take a heat transfer problem, what you do, you need to do first look at the problem and then see how you can accept it. So in the context of conduction and convection, if you know the geometry and the K value and the delta T, you can get a very, very accurate results. Perhaps exactly same as what you get in experiment, you will get what you do if you do a theoretical or numerical analysis. On the other hand, if you're doing convection analysis, things can be very different. As a result, empirical equations are used and the values of H may have large error of margin. So this is what we discussed last week, that this is a standard way of starting the analysis of fins. So এখানে আমরা যেটা করেছি, we have taken, আমি দেখি একটু তোমাদের একটু better annotation নিতে পারি নাকি? If I go there. No, I think the color করছিলাম. No, I think I better stay with this. So এটা হচ্ছে base metal, base material, which is at a temperature, can be any temperature T0, I've written TB. So this is a rectangular fin which is protruding from the surface. And at the same time, this is a similar one, but in this case, we are considering a circular cross-section, uniform cross-section fin. এখানে আমাদেরকে বুঝতে হবে যে এটার উপরে তোমার একটা convection environment আছে. So যখন হিটটা এখান থেকে flow করবে, initially this is conduction, and then as soon as the flow goes along the fin, এখান থেকে surface থেকে heat lose করতে থাকবে, either by forced convection or by natural convection. So that means এই জায়গাটা ফিনটা যদি না থাকতো তাহলে হিট লস হতো শুধুমাত্র বেজ এরিয়াতে. Now since you have increased the surface area, there will be more heat losses, and we want to do the heat loss deliberately, because that's the design issue. That if we wanted to design the heat transfer equipment, one of the requirements that it must dissipate a certain amount of heat, and that certain amount is fixed by the designer, who should have the knowledge of the fins. Okay, আমরা এগুলো ডিসকাস করেছিলাম যে we can consider it one-dimensional if it is if the depth is very high. And one of the things to highlight is if there was only conduction, this line, this shows, say this is the fin, all right? So if it was only conduction, means no heat loss by convection, then it would have been a straight linear profile. But the fact that as soon as it comes here, there is some loss, so obviously dt dx is not constant, and in fact it decreases. So clearly this makes things a little bit more complicated. And then this is what we did. You take a small elemental area, which you are very familiar with, and then we say that the base temperature is T0, and we take an element at the distance of x measured from the base, and then this is the dx. So our infinitesimal area is p times dx. P is the perimeter of this area. Okay, so p times dx is the area of heat transfer by convection. So dq convection is given as h times area delta T. Okay, and if we consider heat coming in is qx and heat leaving at qx plus dx, then we do it like that. So I mean, the heat lost by convection is this, and energy in the left face is minus Ka dt dx. Okay, that's a straightforward given by the Fourier's law of conduction. And the same thing is true. We want to find out the heat lost through the other surface, which is dt dx at a distance of x plus dx. And the way we do it is basically extend it. Dt dx x plus dx means you write the variable and take the derivative of that times the distance, and then you do that. Okay? The regular সঙ্গে পরিচিত সবাই? I hope so.
Yes, sir.
Okay. So an energy lost in convection is this. আমি একবার যখন শেষ হয়ে যাব, then we stop and then we start again. You stay on the line. তো এরপরে আমরা যেটা করেছিলাম, যেগুলোকে আমরা জাস্ট একসাথে করেছি, এবং it needs a bit of a doing, and I hope you can do these things very well. So combine করার পরে you get a second order differential equation in the form of T, which is the temperature. And an interesting quantity that comes up is H times P over Ka. Okay? To make it much simpler, what we do, we take the excess temperature theta to be equals to T minus T infinity, where T infinity means the temperature of the convection environment or outside environment. So if you put those things, you can make it even more simpler. And I'm sure you are familiar with this kind of second order differential equation. So obviously, it's a second order differential equation means you need two equations to solve it. Sorry, two boundary conditions to solve it. One of the boundary conditions is obvious, that when you put at x equals to 0, which means right at this surface, theta equals to theta 0, which is T0 minus T infinity. So that's one of the boundary conditions. And the next boundary condition can have many different types. I have taken from Holman, and perhaps these three are normally considered for an undergraduate studies. So case one, we consider the fin to be very, very long. So your L tends to infinity, which basically means that at the end, the temperature at the end is the same as T infinity. So this is a kind of a theoretical interest. Second case is perhaps more common, that the fin is of finite length and it loses heat by convection at the end. Okay, so I'm sure you agree that this is perhaps the most practical kind of scenario. And the third one is again an interesting one. We are saying that the end of the fin is insulated, so there is no heat loss through the end. So again, the reason that all these three conditions have come up is when you do mathematical analysis, perhaps these three you can do. If it becomes too complex, sometimes people have done it, but again, they become a little bit more complex. But conceptually is nothing more complex. It's just the mathematics, the differential equation solution and the expressions can be a little bit cumbersome and tedious. So যখন ওইটা সলিউশনটা করা হয়, then this is the second order differential equation, and the general equation for this is given by this. Okay, this is a straightforward integration of this expression. And obviously we have got two unknowns. One is C1, another C2. And also a quantity, we write M. M basically means square root of HP over Ka. So let's remind ourselves what is H. H is the heat transfer coefficient, surface heat transfer coefficient. P is the perimeter. K is the thermal conductivity. And A is the area perpendicular to the heat flow by conduction. So that is the cross-sectional area of the rectangular fin in this question. So we know equation 2. Now, the thing is, we have to be able to solve this equation by putting the additional boundary condition. The first boundary condition is known. If I just go back, the first boundary condition is at x equals to x0, you have got, theta equals to theta 0. Now, the second boundary condition is we are applying theta equals to 0, because by the time it goes to infinite length, which is, it should be, I've written alpha, it should be infinity, actually, it should be this quantity. So at x equals to infinity, your theta equals to 0. So you put all those things here and then solve it straightforward, you come to this expression. Okay, so theta over theta 0 is given as e to the power minus mx. And as expected, the temperature, so this is actually giving us the temperature variation over the fin. And I think you are all familiar with the case that when we study heat transfer analysis, if we know the temperature distribution, from the temperature distribution, we can always calculate the heat transfer. And ultimately, for most cases, we are more interested in perhaps the value of the heat transfer. We are also interested in the temperature, obviously, but perhaps Q becomes more important thing to determine in many cases. So we get a solution for case 1, where theta equals to theta 0 and this. So if I ask you then, that what would be the temperature at x equals to infinity? What will be the value? At x equals to infinity, e to the power minus infinity, is it 1, isn't it?
Yes, sir.
Okay, so in any case, you will get the value of theta to be equals to theta 0 theta equals to 0 at the end. So this quantity becomes 0, this quantity becomes 0 at infinity, so theta equals to 0, which is the same which we have considered for our analysis. I mean, this is one of the things I would encourage you to look at, because when you do heat transfer, especially on this topic, you will have loads and loads of equations. And the first thing to check whether those equations make sense. And the best way to check it, check the two boundaries. One boundary is if you put theta x equals to 0, we should be getting theta equals to theta 0, which is exactly the case. If you put x equals to 0, so this quantity is 1, that means theta equals to theta 0. And the second condition is x equals to infinity. That means 1 over infinity means 0, so theta equals to 0, which is the case here. In other words, physically, it means that if the fin is very, very long, what is going to happen? The temperature at the end of the fin will be the same as the temperature of the external environment. Okay, is there any question? Okay, if not, because I'll be down in 3 minutes, can I ask you all to check the dimension of M, this quantity? তোমরা কি এগুলো already পড়েছো কোনো এক সময়? Are these new to you, or you have already done it in your heat transfer? কি একজন কনফার্ম করবে?
না স্যার, এমটা জানি না স্যার।
আচ্ছা, so তোমাদের আমি সবাইকে বলছি, can you check what is the dimension of M? Is it kg, meter, second, whatever? So can you put these dimensions, H, P, K, and A, and tell me what is the dimension of M? Can you all get a pen and paper and put the dimensions, the units, and check what is the dimension of M for me, please? So that's HP over K. So that's watt per meter squared. I write Kelvin. Then, so this is it. এরপরে আসছে হলো P. P is the perimeter. So perimeter dimension কি হবে? Meter is just a
Yes, sir.
distance. Then that divided by watt per meter Kelvin. That's the dimension of K. And I put a second bracket because otherwise it can be confusing. And then what is the unit of area? Meter square. Okay. And what is it then? Can you tell me quickly? What is the unit of this?
Okay.
So what? এটা unit of meter square হচ্ছে? Meter square হচ্ছে না?
জি স্যার।
হ্যাঁ, তার মানে don't confuse this m with this m. এটা হচ্ছে মিটার আর এটা হচ্ছে একটা নাম্বার. So what I'm trying to tell you that this m has got a unit of length. All right, it's not a non-dimensional quantity. It is a dimensional parameter which relates these two things. Okay, and this parameter appears in all the calculations because that makes things a little bit simpler. Okay, so এটুকু আমরা সবাই বুঝতে পেরেছি আশা করি। Okay, so I start the recording.
Recording in progress.
Okay, so তোমরা শুনতে পাচ্ছ আমাকে?
Yes, sir.
And can you see the screen?
জি স্যার।
Okay, thank you. So আমরা যেটা দেখতে পাচ্ছি যে একটা নাম্বার আমরা একটা প্যারামিটার চলে আসছে which is given by equation 3, and this parameter appears in all the following equations. So it's better to get an appreciation of it. So m has got, it's not a non-dimensional quantity, it's a parameter which has got a unit of dimension of length. And perhaps somehow it can be shown that there is some sort of ratio between the convection effect and the conduction effect. Okay, I'm not going into any more details. So if you know this, you can actually work out the heat transfer, the temperature variation along the fin for which case, for case 1. So let's go to the other cases. The second case of finite dimension. So let me just go up and remind ourselves what are the two cases. Case 2 is fin of finite length and loses heat by convection from its end. Okay, and this is perhaps the most common one. কিন্তু যেটা দেখা যায় যে এটার analysis a little bit cumbersome, so all the books will start with case 3 first. And the case 3 says the end of the fin is insulated, so it is such that there is no heat transfer through this end. So that means dt dx is equal to 0 at x equals to L. And then let's derive the expression for that first. Okay, so this is our case 3. Case 3 তে আমরা যেটা পাচ্ছি t squared 3, this is our original differential equation that we have derived from the basics, and this is the solution in the form of C1 and C2, and we now know the value, how we can find out the value of the m. Okay, এখন case 3 boundary condition আমরা যদি apply করি তখন জিনিসটা যেটা দাঁড়াবে, just give me a second. So যেটা দাঁড়াচ্ছে কেস 3 তে আমরা ধরছি যে end of the fin is insulated so that dt dx equals to 0, and to put it, dt dx basically means d theta dx equals to 0. So you can differentiate this expression, okay, and then we get two algebraic equations. This one coming from by substituting the first boundary condition, theta equals to theta 0 at x equals to 0. So you get c1 plus c2. And the second one you get by substituting this condition. So you differentiate the whole thing, and then you substitute x equals to L, and you get that expression. Okay, so obviously this equation looks a little bit messy, but again, you can all do it. It's a little bit tedious, but I would expect all of you to try it at least once. So then, if you substitute, solve for the C1 and C2, and after some manipulations and rearrangements, it can be shown, and that is available in any textbook. So for example, you can look up in the Holman, or you can look up in the DeWitt or in Cropera. You can show that this is the final expression you will be getting. Okay, so you get here that theta over theta 0, again, similar to the previous cases, and you can see that it comes out as an expression like this, an expression like this. And this expression is called sine hyperbolic x. I'm sure you have come up with hyperbolic expressions in the past. I don't know whether you have already used it in any of your engineering applications. তোমরা hyperbolic function কোন engineering application এ ব্যবহার করেছো এখনো কোন সাবজেক্টে? Can somebody tell me?
No, sir.
তোমরা বোধহয় ব্যবহার করোনি, আমারও ধারণা করোনি, but unless you went to vibration or a little bit more complex scenarios, hyperbolic functions do not come. But again, this is an ideal example why we do so many mathematics in engineering, because when you get an expression like this, it's not a very nice expression. On the other hand, if you can express it in the form of sine and cos, this is not sine and cos, we call it sine hyperbolic. And আমরা আগে বলতাম cos and sine. Okay, it's up to you how you remember the variation. So তোমরা এখানে যেটা পাচ্ছ যে theta over theta 0 comes out to be like this. তোমাদের ক্যালকুলেটরে সবারই দেখবে যে একটা hyperbolic function আছে, cos hyperbolic, sine hyperbolic, tan hyperbolic. So again, আগের মতোই theta over theta 0, the temperature variation along different x values. Okay, so again, আমি তোমাদেরকে যেটা বলেছিলাম যে যখনই কোনো একটা ইকুয়েশন পাবে, suppose you have derived it, the first thing you should be checking is whether the boundary conditions make sense. Okay, so for this case 1 of the boundary condition was at x equals to 0, theta equals to theta 0. Okay, can I if we remember, at x equals to 0, theta equals to theta 0. So if you put x equals to 0, that means you have got cos ml at the bottom, cos ml. So that means they cancel, and you get theta equals to theta 0. On the other hand, when it becomes x equals to L, then cos 0 over what? So I think you get that original condition which you can prove from this equation. It's not so straightforward, because in this case, this is dt dx equals to 0. But again, you can show that thing if I can clarify that. So for example, at x equals to 0, d theta dx equals to 0, that condition must hold. So if you then differentiate this quantity and then put x equals to L, I'm sure you will come up with this condition. আমার কথাটা ক্লিয়ার হচ্ছে তোমাদের কাছে?
Yes, sir.
Okay, so again, this is how I look at things, because equations can be messy, can be complicated, but these things have all been done by people more than 100 years ago. Okay, so I can't see any reason really remembering every single thing. You may have to remember some of these, but having an appreciation of these equations and the meaning of it is perhaps more important from practical considerations. Okay, so this is case 3. Now we have skipped case 2 simply for this reason. Case 2টা হচ্ছে যে fin is of finite length and it loses heat by convection from the end. ঠিক আছে? So এই ক্ষেত্রে যেটা হয় the calculation গুলো becomes a little bit messy. All right? After substantial algebra and manipulations, এটা luckily Intropera and Dewey তে করা আছে. So I'm sure you can have a look. You can also find out in many internet websites, reliable websites. These are all done there. I didn't really see much point just going through all of the different steps with you because ultimately it adds nothing to your knowledge apart from a little bit of of how you do the rearrangement and manipulations. So end of the day, once you have done it, you come up with equation 6. And in the equation 6, what we see, again, it is telling the story in exactly the same way. What it is telling is the theta, how it varies with x. Okay? In this case, there is some additional term coming, h over mk, sine m L minus x. Okay? নিচের অংশটা পুরোপুরি fixed, উপরের অংশটা is a variable of x. We cannot say it's a linear variation. Of course not. It's a hyperbolic variation. But again, if we put the numbers there, we all have mighty calculators these days. You can always find out the temperature variation for this kind of thing. Any question at this stage? Okay, I'm assuming you are all comfortable with that. So let's take an audit of the whole thing that we have done. Because if we put the things together, we can start seeing the differences very easily. So if we look at case 1, which is the straightforward one, I call it equation 4 for my case, the fin of infinite length. The second one is the fin is finite length and convection all along, means including the T. Or in other words, we can say the fin is submerged in a convection environment which has got an ambient temperature of T infinity. Okay, and that's certainly, you will all agree that this is perhaps a very realistic scenario for all applications. এবং এই ক্ষেত্রে আমরা দেখতে পাচ্ছি equation 5 is perhaps the most complex, and the last one is insulated tip of finite fin. It is not as simple as equation 4, but this is again a much more doable thing from practical reasons. So in any case, what we do, we have found out the temperature variation of the fin along the distance x for 3 different conditions. There are more than 3 conditions. I think Intropera puts 4 conditions. I'm sure the researchers have found out other different things, but for practical reasons, perhaps what you need is perhaps case 3 equations with some modifications, which I'll show you later on. You can always do these things very, very accurately, and you should do it. But one thing you should remember, that why we are doing these things so accurately, when we know that the value of the age suffers from a big margin of error. Okay, it is good to know the fundamental knowledge, but when you go to the practical engineering world, you will soon find out that engineers deal with loads and loads of approximations. And having your background, solid understanding of the science will always allow you to make the most judicious statement or decision about which way to go. And perhaps that is the main reason that when you solve so many equations in practical life, you will probably see that, oh, I don't need those things. But having this fundamental learning once during your undergraduates gives you the confidence that you can actually move forward and make your decisions in a very knowledgeable way rather than just taking it because it is there. Okay, so these are the 3 equations which actually describes the temperature variation along the fin at different locations of the distance. Any quick question at this stage? Because this is kind of completes our main bulk of the study. তোমাদের কোনো প্রশ্ন আছে কারো এই ক্ষেত্রে?
স্যার এই ইকুয়েশন গুলোর ডেরিভেশন কি পড়তে হবে স্যার এক্সামের জন্য?
I would strongly suggest that you do it at least once, okay? But it is very, very unlikely যে আমি তোমাদেরকে বলবো যে derive this equation. I think it is very unlikely. It's not my thing. I might tell you perhaps equation 4 because this is straightforward one. That just check something. I might ask you, okay, can you come to this stage? I can give you something. But asking you to derive this equation for this situation is something I try to avoid. Okay, so I would strongly suggest that you read the books and see the derivations and do it at least for once. But এটিকে পুরোপুরি মেমোরাইজ করার মতো খুব যুক্তি আমি খুঁজে পাই না। That is my answer. আর কিছু কোশ্চেন আছে?
স্যার যে ইকুয়েশন গুলো আছে এই ইকুয়েশনে আমি যে কোনো লেন্থের জন্য টেম্পারেচারটা বের করতেছি, এটাই তো মেইন মোটিভ নাকি?
হ্যাঁ, যে তোমার ডিপেন্ডিং অন দি বাউন্ডারি কন্ডিশন, যে তোমার এটা যদি ইনফিনিট লেংথ হয় আমি বলে দিলাম, এবং তখন বললাম যে অ্যাট দ্যাট ডিস্টেন্স ফাইন্ড আউট দ্য টেম্পারেচার। ওকে, ফাইনাইট লেংথের জন্য একরকম, ইনসুলেটেড টিপের জন্য একরকম। অলরাইট, তোমরা সবাই তো বোধহয় ম্যাটল্যাব তোমরা ব্যবহার করেছো সবাই?
জি স্যার, ছিলাম।
তোমরা সবাই ইউজ করেছো ম্যাটল্যাব, আর এক্সেল তো সবাই ডেফিনেটলি ব্যবহার করেছো, তাই না?
ইয়েস
জি
স্যার।
স্যার।
ওকে, সো যেহেতু তোমরা এগুলো ইউজ করেছো, ইট ইজ অ্যাকচুয়ালি ভেরি সিম্পল। আমি এই ধরনের একটা তোমাদেরকে হোমওয়ার্ক দিয়ে দিয়েছি, এগুলো আমি তোমাদেরকে সাবমিটও করতে বলবো না, বাট আই উড সাজেস্ট দ্যাট ইউ অল ডু ইট, বিকজ ইফ ইউ ডু ইট ওয়ান্স অর টুয়াইস you get an inner appreciation of the meanings of all these equations, and that is what we call learning. Learning is not about getting marks or just regurgitating things that you remember. More or less you do analysis by yourself. এবং সেই জন্য আমি একটা বলেছি যে এই যে ডেটাগুলো আছে, ইকুয়েশন গুলো 4, 5, 6, you choose different x values, all right, and then choose your own data. Say what is the h value, what is the what is the h value, what is p value, what is the cross section, what is the material, and etc. etc. Then you can actually work out various things. So choose your own data and then compare and comment. But the good thing nowadays is you can actually do these things very, very easily. You are all much better than me because you grew up with these new, computers and everything. You just program this equation in your Excel spreadsheet or MATLAB spreadsheet, or if you want to use other spreadsheet, there are many other available. And then you substitute, say, different X conditions and extract a certain number of data and then plot it on top of each other. You can see how the boundary conditions are affecting the temperature variation along the length for the same material, for the same cross section. আমার কথাগুলো ক্লিয়ার হয়েছে তোমাদের আমি যেটা বলেছি?
জি স্যার।
Okay, so I would strongly suggest that you do it at least once, then you will start to enjoy the subject. আমাদের এইটুকু গেল temperature variation. The next thing is heat transfer from rectangular film. তোমরা যদি নেক্সট ক্লাসে কি এগুলো একজন করে থাকো, ওকে, feel free to show me during the class, or just draw a figure and send me by email. Then I can show it to all the rest of the class. Okay, and that's how we really go deeper and enjoy the whole thing. Okay, আমরা যখন টেম্পারেচার বের করলাম, এরপরে আমাদের প্রয়োজন যে এখান থেকে কতটুকু হিট লস হচ্ছে, ঠিক আছে? So we want to go for heat transfer. So আমরা সবাই জানি যে if it is so this is all of the heat loss. So this is quite interesting, and I think this is the most interesting thing. এখান থেকে যতটুকু হিট লস হচ্ছে, no matter what's the boundary condition, ultimately the heat is flowing through this little area. Okay, so the base area A at x equals to 0, এই area দিয়ে যতটুকু হিট কন্ডাকশনে পাস হচ্ছে, that is the total heat which is actually lost through the film. Think about it a little bit, ponder over what I've just said. যে এখান থেকে যদি বেশি হিট যায়, ultimately where it is coming, the heat is coming through this cross section at x equals to 0. Are you all comfortable with that?
আরেকবার বুঝালে ভালো হতো স্যার।
হ্যাঁ, আমি বলছি যে আলটিমেটলি যত হিট লুজ করছে through the fin, no matter what's the boundary condition, where is it coming from? It is coming from this cross section at x equals to L. Okay, যে এই জায়গাটাতে যে এরিয়াটা আছে, what is that area? Area A. But the area A at x equals to 0, all the heat by conduction must pass through that area and then it is dissipated. And that value is given simply by Fourier's law of conduction, minus Ka dt dx at x equals to 0. And that T will be determined by the particular situation of the boundary condition. Either it is case 1, case 2, or case 3. Whatever be the heat transfer phenomenon, you can do the dt dx and then put at x equals to 0 and then find out the heat loss by conduction at this surface, because that is the heat which will flow through the whole fin, part of which will be lost by convection to the outside environment. So this is a little bit of, I call it food for thought. Think about it, what it is, and I believe it is fairly clear. You can also find out the total heat in a different way. You can basically say, well, heat loss is equals to 0 to L, which means the total length. And what is the heat lost? HP T minus T infinity. Okay, so this is your times dx. You take this little area, all right? So heat loss to this area is HP delta T dx, and then you integrate from 0 to L HP d theta. Okay. Yeah. So that's basically you write down. Yeah, I might have. I'm not sure if I've typed it correctly, but that's the whole concept. I may have a little bit of error there. HP. I think this should be HP theta, then HP theta dx perhaps. But again, this is the concept. All right, I'll check it out before I put this presentation in your Google Classroom. So there are two ways. One is you can actually calculate the total heat loss by convection, but it is the same thing if you calculated the heat loss by conduction at x equals to 0. And this is more commonly employed because it is much more straightforward. তোমাদের ঠিক আছে তো এখন কনসেপ্টটা?
জি স্যার, হয় আমরা এক নম্বর সূত্র ইউজ করতে পারি অথবা ইন্টিগ্রেশন করে করতে পারি।
Integration, but normally this is the one which is used because it is much easier. এবং এগুলো যদি করা হয় for all the three cases, we know the equations of heat transfer, equation 4, 5, and 6. So if you just differentiate it dt dx and then put the numbers, boundary conditions, you get the three equations here for heat transfer. And what is it? You get, for case 1, fin of infinite length, Q is given by square root of HPKA theta 0. Okay, so this is the heat loss when the fin is of infinite length. So this is case 1. For case 2, again, you basically do the dt dx and put x equals to 0. Again, you can see quite interesting. HPKA T0 minus T infinity is basically theta 0, isn't it? I should have written theta 0 here. I don't know why I have written this. So Q equals to this, which is the same that. Then you've got a factor coming in. And that factor basically reflects the temperature variation equation for the second case. And case 3, again, you get this number again, square root of HPKA. You've got this theta 0. So you've got HPKA theta 0 is the same for all three cases. And obviously for infinite length, this is it. If it is a length of finite length but insulated tip, then a little bit simpler. You only have a tan hyperbolic m times L. And when it becomes the most common one, the whole thing is a slightly more complex expression. But in terms of physics, there is nothing new. So if you knew these things, then you can find out the Q, you can find out the temperature variation. Any quick question at this stage?
স্যার ইনসুলেটেড টিপে x ইকুয়ালস টু l, ওখানে t এর
X.
ভ্যালুটা স্যার কত? 0?
Insulated tip, no, dt dx equals to 0, not t equals to 0. The differential, because it goes to such a level that it becomes, the temperature variation becomes 0. So that means it's a curve which becomes parallel to the x-axis at x equals to L. তার মানে এটা ইনসুলেটেড হচ্ছে তো, ইনসুলেটেড মিন্স মানে কি যে ওখান থেকে কোনো হিট ট্রান্সফার হচ্ছে না, ইজ দ্যাট রাইট? সো ওইটাকে আমরা ধরতে পারি যে যদি হিট ট্রান্সফার যখন না হয় তখন কি হবে, তখন ঠিক আগেরটাতেও কোনো রকম টেম্পারেচার ভ্যারিয়েশন থাকতে পারবে না, বিকজ যদি টেম্পারেচার ভ্যারিয়েশন থাকে তাহলে হিট ট্রান্সফার হবেই। সো ইউজিং দ্যাট লজিক we are saying that dt dx equals to 0 means it is equivalent to an insulated tip. Does that make sense?
Yes.
আচ্ছা, আমি দেখি আমি এই কথাটা তাহলে বরং আমি একটু হোয়াইট বোর্ডটা ব্যবহার করি। লেট মি ট্রাই ইফ আই ক্যান ইউজ ইট। আমি খুব সামান্যই ব্যবহার করেছি, বাট লেট মি সি ইফ আই ক্যান ইউজ ইট, তাহলে হয়তো কনসেপ্ট আর একটু ক্লিয়ার হবে। সো লেট মি ট্রাই। এটা বোধহয় আমরা ব্যবহার করি। সো ফার্স্ট আই নিড টু আনশেয়ার দ্যাট, and then I go to the option of the whiteboard. Later, I have to have the whiteboard. Mute. The whiteboard to ব্যবহার করেছি, so somehow okay, all right, let's see. Okay. And not this one. How do I go to the whiteboard? No, I'm sorry, I forgot how to start the whiteboard. Let me use করেছি already একবার. Oh yes, I can go to the whiteboard now. All right, তোমরা এখন whiteboard দেখতে পাচ্ছ?
জি স্যার।
Okay, so আমার মনে হয় এখন আমি বোধহয় হ্যাঁ এখন I'm connected. So let me just go and draw these things. So okay, so এখন আমি যদি this is my first attempt, so please excuse me. So this is the scenario. এখান থেকে তোমার user যেতে হবে. Go to the eraser. এইটুকু ইউজ করছি। Okay, আবার আমি go to the draw and then do that. So আশা করি এখন হবে। তো এইখানে যদি ধরো একটা ইনসুলেটেড টিপ হয়, আমি যাচ্ছি। Okay, so আমি যেটা বলতে চাচ্ছিলাম, so this is your x equals to 0 location and you are measuring x along that. যখন আমরা ইনসুলেটেড টিপ বলতে চাচ্ছি, that means there is no heat transfer to this end. So এটাকে আমরা এইভাবে বলতে পারি না যে এই জায়গায় যদি at the very end heat transfer কখন একদম হবে না। Heat transfer is always given by Q equals to minus Ka, you have dt dx. Okay, so এখানে তোমরা যদি ইকুয়েশনটাতে দেখো, a can never be 0, k can never be 0. So for q equals to 0, that implies dt dx must be 0. Okay, so what is insulated situation? Insulated situation means q equals to 0, which automatically implies dt dx equals to 0. In other words, for this case, the temperature variation would be such that towards the very end, you get a variation. So it becomes a very, very kind of situation, very, very close to the end. It must be parallel to the x-axis. So that your dt dx at this position is taken to be equal to 0. Is that clear?
Yes, sir.
Okay, thank you. Oh, I've done very well. আমার প্রথম এটা আমি ব্যবহার করলাম, so I'm very pleased. Okay, so we go back to where we were before. The whiteboardটাকে আমি cancel করছি. So I start again. So share the screen and go back to my presentation. এখানে আমরা বলেছিলাম. So this is a very, very useful comparison, and this is why I really hated to, to avoid it, not hated, to be honest, avoided deriving all these things, because you can do these things yourself. Just read it when you have time. So basically, we can look at equation 7, equation 8, and equation 9. And if you look at it carefully, equation 7, square root of HPKA times theta 0 is essentially, আমি আবার 10 মিনিট পরে কাট অফ হয়ে যাব, then I will start. So এখানে আসার পরে equation 7 এ তুমি পাচ্ছ এটা, and all the other equations are basically, you have got this whole bit plus some other functions staying in. For case 2 is a little bit more complicated, for case 3 slightly complicated. So again, similar to my previous suggestion, I would ask you all to do these things by yourself. Calculate the Q values for various combinations using Excel or MATLAB. Choose your own data, compare and comment. Okay, does that make sense? Our পরীক্ষার যে প্রশ্ন থাকবে, obviously some of them will need your doing the things by yourself. আমি তোমাদেরকে যে 100টা অঙ্ক করতে বলবো তা না, but obviously I will check your inner understanding of the things, and those understandings are only possible if you do some work by yourself. শুধুমাত্র বইতে যেটা আছে এটা পড়লে সবসময় হয় না. You need to just use your own thinking. এবং I will try, obviously, always set questions which will try to check those who have worked better. All right? So I'm sure you should all be able to do these things. এখন তোমাদেরকে একটা অঙ্ক করতে বলি, যা সময় আছে। So তোমরা যেটা করতে পারো, because I'll be cut off in a few minutes. I think I'll be cut off in 8 minutes. So in the meantime, it would be really useful if you copy this question first, if you write it down on a pen and paper, which will take about a few minutes, okay? And then I shall be with you, but you will be solving the problem while I'm here. So can I ask you all to copy this? যদি ক্লাসরুম হতো, perhaps I would have written it down. অথবা আমি ডিসপ্লেতে রাখতাম, at the same time বোর্ড ব্যবহার করতাম. Unfortunately, আমার দুটো জিনিস হচ্ছে না. So please write it down, the question, by yourself. ইনফ্যাক্ট যারা কপি শেষ করবে করার পরে you can start solving by yourself. So this is about a straight fin of rectangular profile, which has got a K value. The dimension thickness is given. The base of the fin is maintained at a temperature of 200, so that is T0, while the fin is exposed to an environment of 24 degrees Celsius. With H equals to H value is given. Calculate the heat loss per unit depth. Okay, so your depth Z is taken to be 1, and the temperature at a distance of 5 millimeter from the base for the following 3 cases. Okay, so essentially you will be using, okay, so you'll be using equation 4, 5, 6 and 7, 8, 9. Essentially, this is an application use of these 3 equations, 4, 5, 6 and 7, 8, 9. So A is equation 4 and equation 7, B is equation 5 and equation 8, and C is equation 6 and equation 9, 3 different boundary conditions. And as again, I'm expecting you to compare the results for different boundary conditions and then comment on it. তোমরা সবাই এটা কপি শেষ করেছো?
না
একটু টাইম দেন।
আচ্ছা, হ্যাঁ শিওর, আমি সময় দিচ্ছি, যথেষ্ট আমার সময় আছে। সো আরো 4 মিনিট আছে, তোমরা সবাই কপি করো, তারপরে আমি ইকুয়েশন গুলো আবার দেখাবো, so that you can solve it while I'm here. আমি এটাকে একটু ছোট করে আমি একটু লিখতে থাকি, তাহলে তোমাদের আরেকটু সুবিধা হবে। যে প্রথম অংশটার জন্য তোমাদের দরকার হবে ইকুয়েশন 4 and 7, পরেরটার জন্য দরকার হবে ইকুয়েশন 5 and 8। আমি একটু পরে যখন শুরু করব তখন ইকুয়েশন গুলো তোমাদেরকে দেখার সুযোগ দেব। সরি, এটা হবে ইকুয়েশন 5 and 8, সরি, equation 5 and 8 আর এটা হবে equation 6 and 9, case 3, equation 6 and 9। Okay, তোমরা ওইটুকু ইনফরমেশন এখন লিখে নিতে পারো। Then when I come back after I'm cut off তখন তোমাদেরকে আবার ইকুয়েশন গুলো লিখতে দেখাবো। আশা করি তোমাদের সবার শেষ হয়েছে কপি করা এটা।
স্যার
Okay, so let's wait for a few seconds, then I'll cut off, and when I come back, I'll allow you to just copy the equations, the 6 equations side by side, and then I'll show you how to solve the problem. কারণ আমি ব্যক্তিগতভাবে পুরো সলিউশন করার পক্ষপাতী না নিজে থেকে, but I can direct you in the right direction so that you can do it yourself. আমার স্লাইড, ওকে, থ্যাংক ইউ। এখন আমি তোমাদেরকে ওই ইকুয়েশন 4, 5, 6, 7, 8, 9 নিয়ে যাচ্ছি। So you can now copy those, and then probably it will be much more meaningful what I've just said. So if you quickly copy equation 4, 5, and 6 carefully. হ্যাঁ, এগুলো হাইপারবলিক, কস হাইপারবলিক, সাইন হাইপারবলিক। তোমাদের also you also need to write down the meaning that what is m. M is square root of hp over k. So if you could also write down the definition of this. M is just a parameter which makes things a little bit easier. Are you done or few more minutes?
Done, sir.
আচ্ছা সবার হয়েছে? Is there anyone who hasn't copied yet? Okay, so I'm assuming তোমরা সবাই এই temperature variation গুলো লিখেছো এবং these are for 3 different cases, case 1, case 2, case 3. এই তিনটা কেসই বেশি কমন এবং let me just repeat, case 2 is perhaps more realistic scenario. আমরা ফিনটা যেটা বানাই infinite length তো থাকে না, and in most cases it is not an insulated tip. Okay, so case 2 is more common, but unfortunately case 2 calculations involve a little bit more cumbersome expression, but there are practical way out for this যেগুলো আমরা পরের ক্লাসে ডিসকাস করব। তো এরপরে যেটা দরকার হচ্ছে সেইটা এইটা আমি জাস্ট এই যে ইকুয়েশনটা এটা আসলে আমার ভুলটা হয়েছে কোথায়, এটা হবে hp theta dx, সো আমার টাইপিং এ যে ভুল হয়েছে ওটা আমি কারেক্ট করে দেব, it should be hp theta then dx. Okay, so can you all copy these 3 equations please, equations 7, 8 and 9. আগেরগুলো ছিল টেম্পারেচার ভ্যারিয়েশন 3 ধরনের ফিনের জন্য, case 1, case 2, case 3. That was a temperature variation, but in this case it is the heat transfer Q. Okay, হ্যাঁ 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 অনেক, এটা রেক্টেঙ্গুলার অথবা সার্কুলার ফিনের জন্য এটা চলবে আর কি, যেটার ইউনিফর্ম ক্রস সেকশন। আমরা যেহেতু রেক্টেঙ্গুলার করেছি আমরা লিখেছি, তারপরে দেখবে যে there are so many equations you will be overwhelmed, but there are ways to avoid it, so don't worry with complicated expressions. হ্যাঁ রুটের বাইরে, থিটা জিরোটা রুটের বাইরে। সো HPKA এইটুকু হচ্ছে স্কয়ার রুটের মধ্যে আর থিটা জিরোটা বাইরে। I mean, it would be quite intriguing and important that you put all the dimensions and check the expression's value works হয় কিনা, because ultimately this is heat transfer, isn't it? So you should be getting what? ওটা চেক করাটা ভালো হবে যদি চেক করো আর কি। ইনফ্যাক্ট এখানে আমার থিটা জিরো লেখা উচিত ছিল, আমি কেন যে লিখেছি আমি নিজেই জানি না, বাট দিস ইজ থিটা জিরো, isn't it? T0 minus T infinity is theta zero. আমি এখনো ডিসাইড করিনি যে কিভাবে কোশ্চেন করব। I need to follow the norms, what other people use, কারণ আমার যদি মানে we are not used to asking students to remember too many equations, but again I need to follow the norms here, so এই মুহূর্তে আমি ঠিক এটার উত্তর দিতে পারছি না আনফরচুনেটলি। তবে আমাকে যদি জিজ্ঞেস করো ব্যক্তিগতভাবে, আমি চাই না যে কাম্বারসাম এক্সপ্রেশন কারো মুখস্থ রাখা উচিত আর কি, as long as they understand the meaning, that's what is required. আমি তোমাদেরকে পরে বলতে পারবো আর কি যে কতটুকু কাইন্ড অফ নিড টু নো allow me some time. তো আমরা কি মুভ করতে পারি? আর ইউ অল ডান?
Yes, sir.
ওকে, এখন তোমরা যদি তোমাদের তো কপি করেছো নিজে হাতে লিখেছো, so can I ask you to take a very close look between equation 4 and equation 7? জাস্ট দুটোর দিকে তাকাও নিজের চোখে, দেখো কেমন ফিল হয় যে that certainly there is a very interesting similarity. It is the simplest, isn't it? Yeah. Then look at equation 5 and equation 8 side by side. তোমার নিজের হাতে লেখা, so নিজের হাতে দুটোর দিকে তাকাও একসাথে and try to see what are the, I mean, there are two different quantities, but in terms of complication and again expression, there are some interesting similarities. Have a look. And then take a look at equation 6 and equation 9. একটার পাশে আরেকটা রেখে একটু দেখার চেষ্টা করো এবং then you can see some similarities. ওকে, আই থিঙ্ক তোমরা দেখেছো। তো আমি যেহেতু একটু একটা জিনিস শিখে ফেলেছি, আমি আবার একটু হোয়াইট বোর্ডটা ইউজ করি, দ্যাট উড বি কোয়াইট ইউজফুল। এটা তোমাদের নিজেদের জন্যই খুব কাজে লাগবে। সো ইফ আই গো টু দ্য হোয়াইট বোর্ড and then if we do something like this, তোমরা একটা টেবিলের মতো যদি তৈরি করো, টেবিলটা হবে এরকম। এরকম একটা বড় আমরা একটা টেবিল নেই এবং টেবিলে আমরা উপরে লিখি একটা টাইটেল, তারপরে আমরা লিখি তিনটা কেস 1, কেস 2 and case 3. ওকে, সো আমরা এখন যেটা করব, এখানে তোমরা লেখো একটা কলাম, লেটস সে কেস 1, কেস 2 and case 3. সো প্রথম সেট অফ এক্সপ্রেশনস এ তোমরা লিখবে টেম্পারেচার ভ্যারিয়েশন। তোমরা যেটা কপি করেছো ওইটাকে আবার তোমরা সুন্দর করে যদি লিখে ফেলো, and then you write down the Q expression. Okay, আর এর সাথে তোমাদের দরকার হবে to write down what is the value of the M. So M is square root of HP over KA. Job is done. তো তোমরা যখন এইটুকু করবে, and if you write down these expressions which you have already done, but if you put them nicely in these fashions, okay, you will see two kinds of similarity. One similarity along the row, যে এটার সঙ্গে এটার একটা মিল আছে, and another similarity in the vertical direction. That as you move from case 1 to case 3, you can see that there are some terms, যেমন আমার নিজেরই এখন মনে পড়ছে, যদিও বহু বছর পরে আমি এটা পড়াচ্ছি, HPKA প্রথমটার জন্য this is theta 0, এবং পরেরটার জন্য HPKA you have got the same thing, KA, and you have got tan hyperbolic ML. Okay, and the middle one is slightly more complicated. So you have got similarity along the column, along that, and at the same time, there is some interesting, in terms of complication, there is some similarity in that direction. এগুলো আমি বলছি কি কারণে জানো? এগুলো বলছি যে যখন তোমরা প্রবলেমগুলো ইউজ করতে যাবে তখন দেখবে যে if you remember things in this fashion, remembering is never too torturing. Okay, although I'm not too sure whether I'll ask you to remember all, but again, having these kind of conceptual inner understanding will allow you to work through these problems very easily. So ঠিক আছে, এখন আমরা আবার আমাদের এই প্রবলেমে চলে যাই. We now have all the information needed, and then we can go for straight away our problem that we were really, what happened to my, কোথায় গেল? Okay, so এখন আমি why is my mouse there? Okay, so now share it. তোমরা দেখতে পাচ্ছ আমার স্ক্রিন?
জি স্যার।
ওকে, সো এখন আমরা আমাদের প্রবলেমে চলে যাই, কারণ আমরা এই প্রবলেম নিয়ে ডিসকাস করছিলাম. সো উই মুভ টু আওয়ার প্রবলেম. Okay, so this is the problem we talked about, and now we are fully equipped to solve the problem. এখানে আমাদের h value দেয়া আছে, we have got the k value, and we have got the thickness value as well. এবং আমরা বলেছি যে we want to find out at a distance of 5 millimeter এবং per unit depth. So your z is also known. So that's all you need basically, because the length would be variable. এর পরের অংশটা আমি আর কিছু করি না. আমি শুধু জানতে চাচ্ছি যে you use your equations which you have, and can I ask you all, okay, do at least some parts given the time we have. তোমরা প্রথমে x equals to 5 millimeter এর জন্য, can you work out case 1, case 2 and case 3 please? What you will need the calculation of m value first. Okay, প্রথমে তোমরা m টা ক্যালকুলেট করে ফেলো, এবং m টা ক্যালকুলেট করতে যে দেখবে যে না বেশ কিছু একটু ঝামেলা আছে, তাই না? m এর এক্সপ্রেশন হলো h square root of h p k a. So h is given to you, h is 20, k is 10. These quantities are known, so you need to first find out the p value. P is the perimeter, which is 2t plus 2z. Perhaps প্রথম প্রবলেমটাতে আমি একটু আমি নিজেই কিছুটা করি দেখি, আমার যেহেতু বোর্ডটা আছে, so I can do a little bit. তোমরা এটা বুঝতে পেরেছো? Can you all quickly copy this one, because this is how you should really analyze things for the last bit. Case 1, case 2, case 3, 5, 10 and 15 millimeter. So এই টেবিলটা quickly তোমরা একটা jot down করে ফেলো. Then let's work out through P, A, etc. and find out the value of the M. And then you should be able to solve everything by yourself. এটা কপি হয়েছে সবার quickly?
জি স্যার।
Yes sir.
Okay, so আমি এটাকে শেয়ারিংটা স্টপ করছি. শেয়ারিংটা স্টপ করে then I can go to the whiteboard. Okay, so I use the erase all, so I think clear all drawings. Okay, good. Oh, I'm doing very well. So what you need, the first thing you need to do is you need to calculate your m value. So m equals to, okay, so I think I need the eraser. No. Oh, okay. right? So যদি drawতে যাই, stop the eraser. And then draw. Okay. So let me just go to M. So M equals to square root of H P K A. H এর value আমরা জানি, H is given as 20, K is given as 10, and what is the perimeter? আমাদের এটা হচ্ছে যে একটা so perimeter would be equal to, if you recall the geometry, is twice the thickness plus twice the Z dimension. And in this case, so আমাদের যে ফিনটা ছিল এরকম. Okay, so that was the fin, and then that was the T, and that is it. Okay, so এই ছিল আমাদের অরিজিনাল ফিনটা, বোধহয় এইভাবে আমাদের উপরে যেতে হবে না? I think that's how it was. So that was your calculation of X, and then this dimension was T. Okay, and this dimension was your Z. তো তোমাদের প্রশ্নে বলা হয়েছিল যে এখানে per unit depth, so clearly you can take it to be 2 times thickness was 1 millimeter or something. So 2 times 0.001 plus 2 millimeter, 2 meter. So you can put it to be 2.004. Okay, and what is the area? Area is basically this cross-sectional area. So if I can show you the area there, this is your area. So area is nothing but T times Z. So you get the,
thickness is 2 millimeter.
Oh,
Sir,
yes,
X
it's a
equal to
meter.
5 millimeter.
না, x equals to 5 millimeter. কিন্তু আমরা প্রথমে তো m টা বের করতে চাচ্ছি, তাই না? So আমরা সবকিছু মিটারে নিয়ে যাচ্ছি, আমরা এটাকে মিটারে লিখি। So T হচ্ছে 0.002 millimeter ছিল নাকি? হ্যাঁ, 2 millimeter ছিল, sorry, 2 millimeter. So that's 0.002 times 1. So this would be 0.002 times 1. That gives you 0.002 millimeter squared. আমরা সব মিটারে নিয়ে যাচ্ছি। Okay, so if you substitute all these things, can you work out the value of the M for me, please? আমি আর 5 মিনিট পরে শেষ করব, কারণ আমরা অনেক বেশি কথা বলেছি, so 55 পর্যন্ত আমি যেতে চাচ্ছি না. So let's find out the value of the M.
44.76.
Okay, so এটার ভ্যালু আমিও করেছি তাই 44.76. এটার ইউনিট কি হবে? পার মিটার। Okay, তো এখন আমরা m এর ভ্যালু পেয়ে গেছি, so we can now work out the q value. Q equals to, just প্রথমটার জন্য দেখি, square root of H P K A and then theta 0. So you substitute everything there and find out the Q value. Can you do the calculation just for the first case?
Sir, theta naught এখানে 200 ডিগ্রি সেন্টিগ্রেড।
The difference is between 200 minus 24. Theta naught is T minus T0. So T0 minus T infinity. So T0 is 200 and T infinity is 24. Yeah. So 200 minus 24. So if you work it out, you should be getting, আমি জানি না আমার calculation ঠিক কিনা, I got 157.6. Can somebody confirm that? so many
Yes, sir.
watts. Okay, so এইটুকু হচ্ছে হিট লস ফর দিস কেস। আমাদের আরেকটা জিনিস বের করতে হবে, সেটা হচ্ছে টেম্পারেচার। এবং আমরা জানি যে এই সিচুয়েশনের জন্য টেম্পারেচার ডিস্ট্রিবিউশন was T minus T infinity over T0 minus T infinity is e to the power minus x, mx. Okay, so for x equals to 5 millimeter means 0.05 meter. Can you work out the value of the T, please?
$42.77.
I don't think so. It will be higher. Sorry, no, not 0.05. It should be 0.005. I'm sorry, because it's 5 millimeter. Okay, 0.005. 0.005.
164.70.
Yes, 164.7 degrees centigrade. তার মানে ঠিক এই জায়গাটাতে টেম্পারেচার ছিল 200, and just after 5 millimeter the temperature has gone down to 164.7, and then it will continue like this. All right, so you can actually do everything now for other cases. Say x equals to 10 millimeter, x equals to 15 millimeter, x equals to whatever you wanted, 25 millimeter, because আমরা কিন্তু end of the length, আমরা final length সম্বন্ধে কিছু বলিনি except for the case 2. So if you work out those things, and I think you can see the the importance of using a spreadsheet for these calculations, that if you just program it once, you can then use it for a number of different locations, and this is what I expect you to do. আমি এখন কারো কোনো প্রশ্ন আছে এখানে? না, I'm sure nobody has got any. It must be very clear now. So I go there, close it. এখন আমি এখানে যাচ্ছি। Okay, so I think if I share my screen now with you. I'm stuck with it. Okay, so if I go back to my screen, wherever I was, so this is where we are. So we can now repeat the calculations. It's a little bit tedious, but certainly worth doing for case 1, case 2, and case 3 for few locations. And then if you plot all those calculations and put them on the same graph paper, তোমরা সবাই এক্সেলে গ্রাফ, মাল্টিপল গ্রাফ করতে পারো খুব সহজে? শুনতে পাচ্ছ আমার কথা? হ্যাঁ, সো আমি তোমাদের সাজেস্ট করবো, যেহেতু স্প্রেডশিট আছে, তোমরা খুব সহজে এগুলো প্লট করতে পারবে ইউজিং দ্য স্প্রেডশিট and plot them on the same graph paper. একসাথে যখন তোমরা প্লট করবে, then you will start to see the impact of different kinds of boundary conditions on the temperature distribution and the heat loss. বুঝতে পেরেছো? And if you do those things, you will get a real understanding of the meanings of the different boundary conditions, that why these things are happening, how it reflects with your physical phenomenon with the mathematics which is involved. এবং obviously আমি আবারও বলেছি যে আমার যখন পরীক্ষা প্রশ্ন থাকবে, আমি খুব বেশি মুখস্থ পক্ষপাতী না, but having this kind of inner knowledge and understanding of the physical phenomenon is something I'd like to test. Okay, আমার প্রশ্ন কখনো কঠিন হয় না, but that's where I try to emphasize. তো আমি এখন শেষ করতে চাচ্ছি। Have you got any further question? আমি আজকে প্রেজেন্টেশনটা দিব না, কালকে আমার সকালবেলা আরেকটা প্রেজেন্টেশন আছে, তখন আমরা কালকে নরমালি শুধু আরো দুটো প্রবলেম সলভ করবো উইথ ইউ টু ক্লারিফাই দিস কনসেপ্টস, এবং আফটার টুমরোজ ক্লাস I shall upload all the the presentations and everything up to this week. ঠিক আছে?
Yes, sir.
Any quick question from anybody? তোমাদের একটা আমি ক্লাস টেস্ট নেব অন দ্য ফিল্ডস, আমি নেক্সট উইকেও নেব, এবং তারপরে আফটার দ্য মিড টার্ম ব্রেক আই উইল হ্যাভ অ্যানাদার সেশন। সো তোমরা চাইলে ওই উইকেও একটা ক্লাস টেস্ট নিয়ে নিতে পারি অন দিস দ্য টপিক দ্যাট আই উইল বি কভারিং। সো এটা তোমরা আমাকে জানিও। ওকে, তোমাদের সবাইকে অনেক ধন্যবাদ। তো আমি এখন শেষ করছি। সো তোমাদের সবার সাথে আবার কালকে দেখা হবে।
আসসালামু আলাইকুম স্যার।
ওয়ালাইকুম আসসালাম। থ্যাংক ইউ ভেরি মাচ।
স্যার আসসালামু আলাইকুম।